So in this chapter we are going to create a depth layer under the geometry with particles, and so this is the result we want to have. So let's do it. Okay, so now I would like to add a bit of depth overall, just behind the polygon, and I will use particles. So let's add another layer, this other layer I mean, and I will start from this. So here we do have what? The original mesh, and I will take this VDB from polygon to create this layer, and with another VDB maybe reshape to erode, and let's say 3, and I would like to VDB combine both. That's good, and let's set it to SDF difference. So now if I want to check this, I'm going to create my points with a point from volume like this. Okay, so I have 1 point. This is good. Let's say 001, better, a bit more for now. This is good. The scale a bit stronger as well, like this, 1. And I would like for those particles to follow the geometry that is upper of it. So I will need to set it directly inside the noise as well. So let's merge everything there. So like this. But if I am adding the noise there, and I go a bit there as well, my particles are not moving at all, and this is because I don't have the good attributes. So I need the eye cluster and the normal for the direction. So let's transfer it. I'm going to use the near point function as well, and I need it from this one. So I want to add a null there, not you, like this, let's say, and let's call it out eye cluster and n computed, let's say. Is it correct? Let's make a bit more room for all of these. Yes, so that's good, and just get this one inside an object merge, this, and import up with the purple. So let's plug it there, and I want with the near point function, so int near equal near point, not you, and second input, and I would like the what? The eye, no, just the position as a reference for now, and I want the eye at cluster. Oh, forgot this one. And point, looking for the second input, I want the eye cluster attribute and the near ptnum. So that's good, and let's copy past this function again for the normal. So let's say at normal equal 0.1 n. Good. Let's check if it works. It seems to. And let's check as well for the for each, with the for each over the point for the eye cluster. Is it doing something? Yes, 9000. So this is good. Perfect. Let's say transfer the n and eye cluster, and let's set this as red. Transfer n and eye cluster. Perfect. Now it should work. No, it is not, because I don't have the rest position here. So let's set it as well. Rest position. There. Should be alright. No, it is not. Oh. This is my dog. Anyway. So why it is not working? Maybe because of the stage, obviously. I need to transfer the stage. So, and I will just copy paste actually what we have there. This is, you know, the near growth and the transfer stage. So same thing. Exactly the same thing. So this is good. We can even check it with the visualizer. Like this. Maybe with the color. Yes, that works. Good. And it should work right now. Let's take off. Yes, this is good. Let's make it a bit. Oh no, it's not. Oh no. Why? Do I have the stage? Yes. Okay, I think actually it is working, but it's not moving. So I have to set the deformation over this geometry. So in order to do that, I will just use the same technique than usual with the near point. So let's create a new one, and I will get as well this. Maybe not this one, but this one, I guess. Yes. So this is the deformed original. Yes, because there is not a lot of points, so that's good. And I want to transfer the position. So and near, let's call it head equal near point 1 at P. Good. I want the position, so at P equal point 1 up position with the near head. Okay. Now it's moving, but this is not what I want overall because I don't have any layer, and I want to keep the original position, let's say, and just add the direction, you know. So I could use other ways. This is a very fast way, but it's not very accurate as well. So you could use a point deform. You could use maybe the bone deform. No, it's not this one, but there is another one. I don't remember now. But in our case, that's okay because the motion is not very quick, and I will adjust all the result after this operation. So let's do it like this for now, and I would like to, in order to get the same position, add the translation over the time. So in order to do that, I want to have what? A time shift to get the first frame and to freeze the first frame. So let's do something like this. Copy, up, path relative. Good. And let's plug it there. So I want the rest position. So vector rest position equal point. This is the second input, and the position from the near head. This is good. Okay, I need to change this vector, and I need as well the current position. So the current position is the same but for the other one, like this. And I need the direction vector dir equal curve pose minus q minus rest pose. Up, like this. And now I would like to just add the direction, and that's it. Good. Let's see. Yes, it works nicely. But I would like, because it's okay for now, I just have 14,000 points, but at the end I will have 30 billion of points. So I need to optimize as much as I can, and I need, for example, I don't need to operate and compute this operation, this function, for every frame. So I will do it a bit upper and use this attribute. So let's copy, not you, copy past this there. Okay, and I want the same thing. Copy over there, and I want to compute, not you, just the I at, because I need to export it now, and the respose as well. So v at respose. All the other I will do it later. So this is good for me, and let's call it I at as well. Okay. So here I am adding near head attribute, and this is not time dependent, so that's good. This one as well, those are the time dependent, and it starts like this, it starts here I mean, and I can do the transformation there, so I don't need anymore the near head there, neither the rest pose, but the curve position I need to set it with the I at, and the rest position I have to put it like this. Yes. Oh no, it doesn't work. No, it is not working, is it? No. So why? Because I don't have the right input there, so it's taking 0 and make a scale. Okay, and it should be right now. Let's see with the, yes, this is good, perfect, and set deformation, and we want something black for this one. Okay, this is good. Now it should work with the noise, and I think it's okay. Yes. And I would like to check it with the primitive as well, so let's do it there, but I don't want the particle motion, so apply it from this one. But I don't have my particle anymore, so maybe I should create a group over there, like this, group. From point, and let's call it particles. This is nice. And I want to split before the motion of over the primitive. So let's go there and let's say particles. Yes, this is good. But I don't want this, I want the other to plug there. Okay, this is what I want, and I want to merge with my particles and maybe set a color as well to make a better visualization. So let's do a color like this. I don't know, a red one and a green one for the particles. 0, 1 and 0. Good. Oh, but I have something. Okay, that's good. Let's add a bit more particles. So let's say 2. Okay. So I think it's quite good, right? But I don't want to see all those points outside of the geometry. So in order to avoid that, I have done an example file. Oh, this should be red. Because I am using a technique, and it will be easier for me to explain it with this example file. So let's do something like this. Okay. Okay. Up. This is better. So let's get our example file. It is just there. Copy, paste, not you. Okay, I want green. And let's have inside. So here we have a sphere with the UVs, the normal, a color just to make a better visualization, and I've set a switch from a blasted sphere like this to the original one, and a transform to move everything like this. On the other side I have a box and a point from volume to get point from this box, and the color to have a better visualization as well. And if I merge everything, I have this. Because here there are three different ways to say if the points are outside of the geometry, then stick it and move it to the surface. So the first way there, as you can see, is using the group. With the enable bounding object, I'm creating a group in, and then I'm setting the minimum position from the opposite group. So this is good. But the problem with this technique is it's not going to work with, as you can see there, if there is some holes inside the geometry. And unfortunately we do have some of them, so we need to find other ways to make it work. So there is two different ways. The second one is very fast and is good, and this is the one we are going to use. It's using the near point function to get the near normal as well, the near position. And then here I'm saying if the dot product from the direction, from the position to the near pose, and the near normal is inferior than 0, then let's create a group. So what does it mean? It means that if I take off this, I go back there, it means, for example, if I'm taking this point and I'm looking for the near point, so it will be something there. I want the vector from this to this, so vector like this, okay? And I want the normal as well, so the normal will be something like this. And if I'm doing dot product, I will have a value like -1 or -0.5, and it means that if it's less than 0, it will be a negative, it will be the opposite vector, and then it means this is inside. So this is the calculation we are doing there, there and here. After setting the group, I'm just saying that if it's the opposite of in, then let's stick to the surface. So this is good, this is what we want and this is what we are going to use, but there is a problem as well with this technique, and let's take a look. If I decrease the number of polygons, as you can see, it's not working anymore, okay? And this is because there is not enough points. So it's okay for us because we are going to use a very high-res mesh, so that's good. But if it was not the case, we will have to use another technique. And this is the other technique. So this is the perfect technique, let's say, but it's, as you can imagine, longer than the others. So this is the same process than the previous one, but I'm using the XYZ dist by creating new primitive attribute and the new UV as well. I'm taking the sample normal from the geometry surface and the sample position as well. So it means it's not necessary to have points, because it's going to look directly to the geometry to have the nearest point and the nearest normal, the nearest sample position and the nearest sample normal as well. So this is perfect, and we just with the same operation there need to say if it is outside, just set the position to the near pose. Okay. So I think it's good, but we are going to use the second one because between both of them, with all our particles, we will have something like 30 seconds of difference for each frame, so it's not good for us. So let's go back. So let's import the geometry that I want to ray over it. And this is this one, because it needs to be accurate and I need to have the same exact remeshed geometry. So this one. Let's take it. And there, object merge. Let's see, import. Like this, and like this. Purple color. Okay. Attribute wrangler. Because of the deformation is not very accurate, because I am using this way, I will need to iterate over each frame with this operation. That's okay. I mean, this is the fastest way that I found. Maybe there is a better way, I don't know. But I'm using this one. So let's create what? We need the normal. Do we have normals there? No, we don't. So I would like to create some facet there, and let's say post compute. Should be alright. Let's see. Yes, this is good. Perfect. So let's go back to our node there. Okay, take off maybe the color, and I want near. I want the vector near normal, and I want the vector near pose, and I would like to create the vector direction from it. So let's do the near point, not you, like this. I want the second input, and I want the position as reference. For the second one, I would like to use the point function, the second input, the normal, and the near pitinum. Same thing for the position. I want to copy paste this function and use it, but with the position, like this. And for the direction, I want what? I want at p minus near pose. So this is good. And I would like to normalize this result as well, because you have to normalize something in order to get a good result with the dot product. Normalize, like this. Okay, now if my dot product returns, so between the direction and the near normal, like this, is inferior than 0, I would like my group E at, it's not a group, it's an attribute actually, equal 1. Okay, so now I would check it with another one, and let's say at cd equal something like this. Let's put it green with the at in equal 1. Let's get back the color, and it doesn't work because of the visualizer. Let's not update this one. So it means I will see the result just with over this node, but not there anymore. There, yes, I do. No, it's because of this one. Actually, I don't need this function anymore. So this is the color, you know, from the custage, not the custage, the growing solver. So I don't need it. And maybe I could delete it as well over there. Yes, it would be better and faster. So now I have this one, and here I don't have anything more. So this is good, and I can check it. So as you can see, I made something wrong. It means I've done something here. It's not the correct let's say operation, and it should be the opposite. So that's good. So all those points are outside my geometry, and I would like to, if it's the case, get array. So the same at position equal min pose from the second input and the position as reference. So if I check it, like as you can see there, this is moving. So let's rename all of those. Add in attribute, red color, and set, yes, to surface, maybe. Good. Like this. So let's check with everything how it works. Okay, let's active it, take it off. Okay, it's a bit better. but not exactly what I want. So I would like to get more separation between this one and what is inside or not. So I will use a pick just to make all those polygons go a bit inside, you know. So let's do, no, it's a bit too much, like this. Let's see the result. That's good to me, except for this one. They shouldn't be like this. Okay, I think it's because of the vertex split. I have to do this. So I got UVs over the eyes. I don't need them, but because of the vertex split, it split the geometry there. And if, for example, I'm doing an exploded view, yes, this is what I've got. So I don't want that. I would like to use the vertex split, but not over the eyes. But I have an eyes group there, but it's on the primitive, so let's promote the group to the points. Like this. So I want the eyes from the primitive to the points, and I want to keep the original as well. Okay, and now on the vertex split, I want everything except the eyes group. Good. Let's check if it works. Yes, it's good. So nice. I would like to check as well if we have the good result for our UVs. So UV quick shade, and this is good. So perfect. Let's go back there, and maybe with this adjustment it should work actually. And go back there. Yes, this is good. Okay, perfect. So now I would like to check this with the rendering, because we might adjust a couple of operation attributes and things like this. So let's do that.